Hi, everybody. Today we're going to look at the power rules for exponents, and this is actually it. This is all of the exponent rules that I think you ever learn. In later grades, you just extend them to using fractions and negative numbers as exponents, but the rules actually don't change. So this is good stuff to know. All right, we're going to start with looking at the power rule, raising a power to a power. So we're going to look at the example of evaluating 4 squared all cubed. First, we're going to write it as a single exponent and then evaluate it. So let's look at what this actually means. We have 4 squared cubed. So the 3 exponent is applying to everything that's inside the brackets, right? That's the bonus rule I keep talking about. The exponent only affects what it's touching. So this actually equals 4 squared times 4 squared times 4 squared, right? And we can write that out as 4 times 4 times 4 times 4 times 4 times 4, which is 4 to the 1, 2, 3, 4, 5, 6, 4 to the 6. Or we can apply our multiplication rules to this, and this becomes 4 to the 2 times, sorry, 2, 2 plus 2 plus 2, right? Which is 4 to the 6, either way, all right? Um, or we can apply the exponent law, and the exponent law of raising a power to a power says that a to the power of m raised to the power of n is a to the m times n. So you're going to multiply those two exponents together, which makes sense because if we come back up to the top here, that's what we did. We went 2 plus 2 plus 2, which is the same as 2 times 3. And if we look at the expanded multiplication, we had 2 here and 2 here and 2 here, so that was 3 groups of 2, gets us 6. So if we use the exponent law, we have 4 squared cubed equals 4 to the 2 times 3, which is 4 to the 6. So there's our answer as an exponent. And then to evaluate it, we need to use a calculator, and it's 4 to the power 6, which is 4096, 4096. All right. Let's take a look at example 2. This one's a little bit more complicated because of that negative sign. It's going to be, so I'm just going to rewrite it, it's negative 5 cubed squared. So this is going to be negative 5 cubed times negative 5 cubed. And I have to pay really close attention to that negative sign. So there's a couple of ways that I can do this. One is I can, if I were to expand this negative 5 cubed, that would be negative 5 times 5 times 5 times the same thing, negative 5 times 5 times 5, because remember this 5 is not being, or the negative is not being cubed, only the 5 is being cubed, right? So this is going to be, the negative and the negative cancel each other out, so this is going to be just 5 to the 6, okay? Or I can use my multiplication rules, but I have to pay really close attention to this negative 5. So I should probably write this as negative 5 cubed times negative 1 times 5 cubed. All right, and then that's going to be the negative times the negative is plus, and 5 to the 3 plus 3, because I'm adding the exponents. So that's 5 to the 6. Either way, it's the same answer. And then if I evaluate that, I get 1, 5, 6, 2, 5. If I use the exponent laws, I have to be really careful with this. Again, because that negative sign is not within the brackets here. Basically, I'm going to just have to figure out if my answer is positive or negative uh, just by looking at the question and deciding that. So if I look at the inside bracket here, this whole thing is going to be negative, and then I'm going to square it, which is going to make it positive. So I know my answer is going to be positive. So I might just put a plus there to know that I've examined that and I know my answer is positive, as opposed to I forgot to think about it. And then it's going to be 5 to the 3 times 2, which is going to be 5 to the power of 6. Okay, your turn. Give that a shot, and then check your answers. All right, how did you do? That's I think these rules are all pretty straightforward. It's just a matter of remembering to use them, and using the right one at the right time. All right, let's look at the next example, raising a product to a power. So if I gave you a question that said this 5 times 4 all squared, you would follow your order of operations and you would do what's inside the brackets first. So this would become 20 squared, which is 400. And that's all well and good when you have numbers, but if somebody throws letters in there, this doesn't work anymore. So we need a technique that will work with letters as well. So let's try this, doing it using repeated multiplication. So 5 times 4 all squared equals 5 times 4 times 5 times 4. And I can rearrange that to be 5 times 5 times 4 times 4, right? Which I can then rewrite as 5 squared, 4 squared. Now I could put a dot in here. Maybe I should. I don't technically need to, because the squared separates the 5 from the 4, so I know it's not 54. But there's no harm in putting that multiplication symbol in there. And then I can multiply this out, and I get 25 times 16, which equals 400. All right, but what I want you to see is we moved from 5 times 4 all squared to 5 squared, 4 squared. So the exponent gets applied to both things in there when they're multiplied. Okay, so the rule here is that if I have AB to the power of m, so A and B represent any numbers, this becomes A to the power of m times B to the power of m. All right. Let's do an example using, let's just come back and apply the exponent rule here. So this is 5 times 4 all squared equals 5 squared times 4 squared. And you will be asked to do that, to write something as a product of two powers, and that's what that means. This is a power, and this is a power, and this multiplication says it's the product. Okay? And then evaluate means tell me what it actually equals, and this one equals 400. All right, example 2, write as the product of two powers, and then evaluate this algebraic term. So I've got a squared b cubed to the power of 4. If I do this using repeated multiplication, I have a squared b cubed times a squared b cubed times a squared b cubed times a squared b cubed, and there's 1, 2, 3, 4 of those. And I can rearrange this. This becomes a squared times a squared times a squared times a squared times b cubed times b cubed times b cubed times b cubed, which is a to the 2 times 4. Actually, I should write that as a I could write it as 2 plus 2 plus 2 plus 2, and then times b to the 3 times 4, or 3 plus 3 plus 3 plus 3. Either way, I end up with a to the 8, b to the 12. But that was really tedious, so let's just use the exponent laws. And then this becomes a squared b cubed all to the 4 equals a to the 2 times 4 times b to the 3 times 4, which is a to the 8, b to the 12. Please write this step out. Please just do yourself that favor and write it out. It doesn't take very long, and it does help you to remember that you're multiplying and when you're adding and when you're doing different things. Writing it down really does help make that connection in your brain stronger. All right. Pause the video and do these two examples, the your turn questions, and then come back and check your answer. Okay, notice that I don't evaluate the example B here, a to the 15, b to the 15. I can't evaluate that because I don't know what a and b are, so I can't simplify that any further. However, in a, I can multiply those numbers and get a number of 1,296. That is the evaluation of that expression. All right, let's look at raising a quotient to a power. This is the last new concept here. When we write as the quotient of two powers and then evaluate. So 2 over 5 to the power of 5. So if I do this as repeated multiplication, 2 over 5 to the 5, well, my 5 exponent 5 is applying to everything in the bracket. So it's 2 over 5 times 2 over 5 times 2 over 5 times 2 over 5 times 2 over 5, which I can then multiply all those fractions together, and I get 2 times 2 times 2 times 2 times 2 all over 5 times 5 times 5 times 5 times 5, which simplifies to 2 to the 5 over 5 to the 5. And then to evaluate it, that's 32 over 3125. And that will not reduce because there's no common factors between the top and the bottom. Using the exponent laws, I hope you noticed that the exponent 5 just got applied to the top, the numerator, and the denominator. All right, so the exponent law here, trying to do too many things. The exponent law is that a over b raised to the m equals a to the m over b to the m. Okay? So if we apply that here, 2 over 5 to the 5 equals 2 to the 5 over 5 to the 5. That was pretty straightforward, wasn't it? So this equals 32 over 3125. All right, let's do an example using variables. So we have a cubed over b squared all to the 5. This is a cubed over b squared times 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 a cubed over b squared. This equals a cubed times a cubed times a cubed times a cubed times a cubed. So it's a to the 3 plus 3 plus 3 plus 3 plus 3 all over b to the 2 plus 2 plus 2 plus 2 plus 2, which equals a to the 3 times 5 over b to the 2 times 5, which is a to the 15 over b to the 10. Well, that was long and tedious, wasn't it? Let's try it using the exponent laws. So I have a cubed over b squared all to the fifth equals a cubed to the fifth over b squared to the fifth. Now I maybe didn't need to actually put those brackets there, but it's not a bad idea because if there was a negative sign here, um, the 5 exponent does apply to everything that's in the numerator, right? And there are always those invisible brackets right here, right? We don't write them, but they're actually there. So putting the brackets here can help you, especially if there's negatives, help you clarify what's going on. So this becomes a to the 3 times 5 over b to the 2 times 5, or a to the 15 over b to the 10. So I don't know about you, but I found using the exponent laws a whole lot easier than writing it out the long way. All right, let's do one more example. Oh no, this is a your turn. Why don't you give this one a try? This is a challenging question. Give it a try. So my 4 exponent applies to everything that's in the inside the brackets, right? So it becomes 3 to the 4 times a to the 3 times 4 over 2 to the 4 times b to the 5 times 4. So 3 to the 4 is 81, and this is a to the 12. And 2 to the 4 is 16, b to the 20. Okay, hopefully that made sense to you. I did, we did skip a couple of steps in there, but I'm hoping that you could follow that. All right, let's look at some common mistakes that happen. You cannot apply any of these rules if there's a plus sign inside here. It only for multiplication. Only applies for multiplication, not for adding. If it's addition, you have to, there's a different way you do it, which you'll learn next year. But you can't apply the exponent rules if there's a plus or a minus inside there. And for this one, example 2 here, what happened? They added, oh, it's just clarifying that when it's a power times a power, you add the exponents, and when it's a power to the power, you multiply them. Okay, so just be really aware of that. Okay, there are some practice questions here in your notes package, and then there is more practice in your textbook. So make sure that you do both of those and check the answers. And I will see you in the next video. Bye.